Good day, boys. Good day, girls. How are you? Hope you are well. Hope you are fine. Today, we will carry on with our mathematics lesson. And then our topic today will be revision of the works that we did from the beginning of the lesson, from the beginning of the term, in preparation for the assessment you are writing on Monday. Okay, so we're going to be going over the work we did. Today, we'll be starting with the revision of algebra. Before I carry on again, my name is Abdul Jafaru Abdullahi, and then our topic today will be revision of algebra and patterns. And this will enable us to prepare for our exams for Monday. So at the end of today's lesson, we should be able to solve different algebraic form of equations, different algebraic form of equation and expressions, and to solve problems involving number patterns. Okay, so start off with the exercise 1. It's saying factorize completely. Factorize completely. 6p plus 40 minus p squared. We need to factorize this. How do we factorize this? So usually in factorizing trinomials of this nature, we prefer the coefficient of the p squared to be positive. We prefer the coefficient of the p squared to be positive. So this is the standard form. So what we do, we try to rearrange it, or we try to factorize with a -1, so that we have a negative p, we have a positive p, and then -6 and -40. Okay, we try to factorize in such a way that we have a positive p squared, and to get that is to factorize with -1. So take out -1 in a bracket, then you have what? Positive p squared minus 6p minus 40. And then we can now factorize by looking for two factors in such that when we multiply the two factors or the two numbers, we get what? -40, and when we add them, we have -6. Okay, so we're saying again that we factorize p squared minus 6p minus 40. And then to factorize that, we look for two numbers. The two numbers must be that when we multiply the two numbers, we must get -40. And then when we plus them, when we plus the two numbers, we get -6. So what two numbers can this be? The two numbers can only be -10 and +6. So with -10 and positive, because -10 and +4. So we have -10 and +4. -10 times +4 give us -40, and then -10 and +4 plus +4 will give us -6. So this will be our factors, and then with that we factorize our trinomial. Again, we have 6p minus 40 minus p. So we're saying we prefer our value of p squared, the coefficient of p squared, to be positive. So to do that is to pull out, to factorize using -1 or just a negative. So factorizing with -1 out, so we're going to have positive p, we're going to have -6p, positive p squared minus 6p minus 40. And then you look for two numbers. When you multiply them, you get -40. When you add them, you get what? -6. So the two numbers are -10 and +4. Because -10 times +4 will give you -40. And -10 plus +4 will give you -6. So like this, you factorize, you open two brackets, you put p in the first bracket, p at the other one, then you have -10 and +4. And then that is factorized. Okay. So that is that. Then the next one, 2.2. We factorize completely -xy minus brackets y minus x bracket b plus b squared. To factorize this completely, so this here, we need to first of all open up the brackets, and then we group them. We factorize this by grouping. Okay, we factorize this by grouping. So, and to do that, we need to first have to open up the b, open up the bracket by multiplying the b with the content of the bracket. We're going to have -xy minus by plus bx plus b squared. Again, you have -xy minus by plus bx, then plus b squared. Then you can now put your -xy minus by in one bracket, and then the plus bx, and the b squared will be grouped in one bracket, and then you can factorize. Okay. So we have our question as minus xy minus y minus x times b equals to plus b squared. So we're saying we're solving this by grouping. But before grouping, we need to open up the bracket. So minus b times y gives you minus by, minus b times x gives you plus bx, minus b times minus x gives you plus bx, then plus b squared. And then we can now group these two. We group these two here, and then we group these two. So, and then if we check it now, what will be common here? Y. The common term here will be y. So negative y, and precisely, we have negative y bracket x plus b. Negative y bracket x plus b. Then for this other side, if you group these two together, the common term will be b. With bx and b squared, b will be common. So bring out your b, you have in x plus b, and then you're going to see that x plus b and x plus b are common in these two terms. We take one of them and put minus y and plus b in one bracket. So we have x plus b times minus y plus b, and then it's factorized. I hope you understand that. Okay, right, we're done with that. So the next one, exercise 2, solve for x. Solve for x. So we have to solve for x in this equation. We have to solve for x in this quadratic equation with fraction. It's a quadratic equation with fraction. So how do we solve for x here? So this, that is a trinomial x plus 2 over x squared minus 3x minus 4. So the first thing to do is to factorize this trinomial. When you factorize this trinomial, then you can see what it gives you, and with that you can compare with the rest of the denominators. With that, you can be able to determine what your lowest common denominator LCD is. So you need to factorize this. So when you factorize this, then we see how it compares with this and this, and from that we can determine our lowest common denominator LCD. Okay, so factorizing the trinomial, so we got x squared minus 3x minus 4. So we look for two factors. When we multiply, we get minus 4. When we add, we get what? Minus 3. So what two numbers we multiply to give us minus 4? When we add them, give us minus 3. So that can only be minus 4 and minus 1. Minus 4 and plus 1. Minus 4 and plus 1. Minus 4 times plus 1 will give you minus 4. And minus 4 plus 1 will give you minus 3. Okay, so our factors are minus 4 and plus 1, because minus 4 times plus 1 will give us minus 4, and minus 4 plus 1 will give us minus 3. Okay, so with that, we factorize the trinomial, and then we're going to have x minus 4 and x plus 1. So with this, yeah, this is going to give us x minus 4 and x plus 1. So here we also have this as x minus 4. Here we have 2 plus 2x. So this on its own can be factorized. So this here it can be factorized because 2 is common here. You take out your 2. When you take out your 2, you're going to have x plus 1. So you're going to see that we're going to have x plus 1 here. You're going to have 2 into brackets x plus 1. We're going to have x minus 4 here. Here we're going to have x minus 4 and x plus 1. So from there, you can say that you can determine our lowest common denominator. Okay, let's see from this our solution. So this is our solution. This is our question. X plus 2 over x squared minus 3x minus 4 equals to 3 over x minus 4 minus 1 over 2 plus 2x. So you're saying the first thing is to factorize this trinomial. Factorize that when you get x minus 4, x plus 1. Okay. And then this one says this is 3 over x minus 4. This is 1 over. Factorizing this, because this can also be factorized. We factorize this, we get 2 into x plus 1. So this x plus 1, this x plus 1, this x minus 4, this x minus 4. And then there's a 2. So therefore, our lowest common denominator will be x minus 4, x plus 1, and what? Times 2. So our LCD will be 2 times x minus 4 times x plus 1. That'll be our common denominator, our lowest common denominator. So what do we do with the lowest common denominator? We multiply the lowest common denominator with each and every of the term. We multiply each and every of the term with the lowest common denominator. So this one is a term on its own. We multiply it by the lowest common denominator. This another term, we multiply it by the lowest common denominator. This another term, we multiply it with the lowest common denominator. Okay, so multiplying this with the lowest common denominator, we 2 into x minus 4, x plus 1. So if we times that with this, so be left with just 2. And then 2 times, we're having 2 times x plus 2 on the left. And then if you multiply this first term with your lowest common denominator, we'll be having 3 times x, 3 times 2 times x plus 1. And then 3 times 2 give you 6, 6 times x plus 1. Okay. And then the third time, if you multiply by the lowest common denominator, we'll be having 1 times x what? X minus 4. 1 times x minus 4. So we'll have 1 times x minus 4. Okay. And then after that, we're going to have this, and then we're going to expand this here now. So 2 times x give you 2x, 2 times 2 is 4, then 6 times x is 6x, 6 times 1 is 6. Then negative 1 times x give you negative 6x, negative 1 times negative 4 give you positive 4. And then now collect your like term there. Put your like ones together. 2x, 6x minus x gives you 5x. Bring your minus 5x over to give you negative 5x. And then 6 plus 4 is 10. And then take your 4 over, that'll give you 4 minus 10 minus 4, that is 6. So basically, minus 3, 2x minus 3 minus 5x is minus 3x. So minus 3 equals to 6, x equals to minus 2. So our x equals to minus 2. Okay, our x is minus 2. Right, so I hope you understand that there. Now the next one says, solve for x if x is an element of real number and illustrate your answer on the number line. So we need to solve for x here. If it's minus 3 is less than or equal to x over 2 plus 1, and then that's also less than 3. How do you solve for x here? To solve for x here, what do? We first have to move this one to both sides. Move the positive one to here, to the right hand side to become negative 1. We do the same thing to the left hand side. So you move the positive one to the right and also to the left. So move this to the right, you're going to have what? 3 minus 1. I'm moving it to the left to give you minus 1 minus 2, that'll be minus 3. So basically we have what? Minus 3 less than or equal to x over 2 less than what? 2. Okay, and then to now get rid of the 2, to remove the 2, we now times there is dividing, okay? When we're dividing, if you are going to take it to this side, it's going to be the inverse. So the inverse operation will be multiplying. So we're going to multiply the 2 here by 2, and then the negative 3 here by 2. And we'll have here negative 6, and then we have here 4. So we can have what? Minus 6 is less than or equal to x, and x is less than 4. Okay. So we explained that this here is our question. We move this one over to give us 2. We move this one over to give us minus 2 minus 1, which is minus 3. So we have minus 3 is less than or equal to x over 2, which is less than 2. And then to get rid of this what 2, we multiply the right hand side and left hand side by 2. So also this one multiplied by 2 gives us x, this one multiplied by 2 gives you 4, this one multiplied by 2 gives you negative 6. So therefore negative 6 is less than or equal to x, and x is less than 4. So basically x is greater than or equals to negative 6x, and x is less than 4. That means x has values between negative 6 and what? And a value less than 4, which is 3. Okay, so this is our answer. Now to now present this on the number line. Present this on the number line. Then we say you should draw your 2 circles. After drawing your 2 circles, then we now draw the 2 circles and then join the 2 points together. Join the 2 points together and then join the 2 lines. Okay, you join the 2 lines together and then we're going to shade this point. We're going to shade this point. The circle will be shaded because x is less than negative 6. X is less than negative 6. Okay, so with that, we get our point here. Okay, with that, we get our point here. All right, so we're going to have from minus 6 to 4. So our values of x are between negative 6 and positive 4. Negative 6 and positive 4. Okay, now the next one. So let's see the next question there. So this one is done. Then we can go to the next question there. So the next exercise 3. The following pattern is given: 5, 8, 11, 14. 5, 8, 11, 14. Determine the general term of the pattern. Determine the general term of the pattern. How do you determine general term of the pattern? How do you determine general term of the pattern? So what type of pattern is this, first of all? We need to first of all determine what type of pattern is this. Okay, so we see there are three types of pattern. We have the linear pattern, the exponential pattern, or the geometric pattern, and the quadratic pattern. In a linear pattern, we have a constant common difference. In a linear pattern, we have a constant common difference. So that means our T2 minus T1 must be equal to T3 minus T2. And that must be equal to T4 minus T3. So that's for a linear pattern. For a geometric pattern or exponential pattern, we have what called the constant common ratio. The constant common ratio, we say T2 divided by T1 must be equal to T3 divided by T2 must be equal to T4 divided by T3. So if there's a constant common ratio, then it's a exponential pattern. And then for the quadratic pattern, which we're going to learn in grade 11, we have what called the constant common difference, the constant second difference. Okay, let's look at this now. 8 minus 5 is 3, 11 minus 8 is 3, 14 minus 11 is 3. So here there's a constant common difference of 3. There's a constant common difference of 3. So with that, we can now use our Tn formula for a linear sequence. So the Tn for a linear sequence says what Tn equals to a plus n minus 1 times g. The Tn, the general term, the n term is what Tn equals to a plus n minus 1 times g. Okay, so with that, our a is our first term here, which is what 5, and our d is our common difference here is what 3. So we substitute that into the Tn formula and find our general term for the sequence. So again, the formula is Tm equals to a plus n minus 1 times d. Okay, now we're saying now our a is what? What's the value of our a? The value of our a is what? 5. Okay, the value of our a is 5, and then our common difference is 3. So we're going to have what? 5 plus 3. We're going to have 5 plus 3 into 5 plus 3. Tn equals to 5, which is our a, plus bracket n minus 1 times d. So we're going to have 5 minus 3 minus 3n. From 5 minus 3, which is what 2, then 2 plus 3n. Okay, so when you do that, we're going to have what 3n plus 2 or 2 plus 3n. That'll be our general term. Okay, our general term will be 3n plus 2. Okay, so 3n plus 2 is our general term for the sequence. Right. So the next one says determine general term for 3x minus 7, 2x, 3x plus 1 are the first three terms of a linear pattern. 3x minus 7, 2x, 3x plus 1 are the first three terms of a linear pattern. If the pattern continues in this manner, determine the value of x. Determine the value of x. So we have been told that this here is a linear pattern. Because it's a linear pattern, that means there must be a constant common difference. And how do you get your constant common difference? You see your second term minus your first term. It must be equal to your third term minus your second term. So basically, we try to create an equation from there. Since we know our difference must be equal. So we're going to say 2x minus bracket 3x minus 7 must be equals to 3x plus 1 minus 2x. And then we can now solve for our value of x. So this being the first, second, and third term, so because the linear pattern, so we're going to say T2 minus T1 has to be equal to T3 minus T2. So T2, which is 2x, minus T1, which is minus 3x minus 7, must be equal to 3x plus 1, which is your third term, minus the second term, 2x. With this, we factorize, we solve for value of our x. We bring down your 2x, then open up the bracket to get minus 3x plus 7. It equals to 3x plus 1 minus 2x. Okay, so 3x minus 2x will give us x plus 1. And then this one gives us 2x minus 3x, you get what? And then bring the x over, that'll give you minus 2x equals to, bring the 7 over, negative 6. 1 minus 7 will give you negative 6. So minus 2s equals to negative 6, so s equals to 3. So the value of our x there is 3. Okay, the value of our x is 3. So the next question, which sum in the sequence is the first to be greater than 31? Which sum in the sequence is the first to be greater than 31? So how do we answer such a question? Which sum in the sequence is the first to be greater than 31? So the first thing to do is to find our real values of the sequence. We need to find the real values of the sequence. Getting our x as what? 3. Our x being 3, our x being equal to 3, then we find the real values of the sequence. So 3 times 3 is 9, 9 minus 7 is 2. So the first term will be 2. So 3 times 2 is 6. So the next one will be 6. Then for the third term, 3 times 3 is 9, 9 plus 1, 9 plus 1 is 10. So that will be 10. We're going to have 2, 7, and 10. Again, here is 2, here is 6, and there is 10. 2, 6, 10. So that's our sequence. So that means our first term is 2, our second term is 6, and our third term is 10. So now we can see that the difference there is what? The difference between them now is what? 4. So now with that now, with our sequence, we can now create our general term. Okay, we generate our general term. So this is our sequence 2, 6, and 10. Okay, so with this our sequence, we generate our general term. What's the general term? If the general term again is Tn equals to a plus n minus 1 minus n minus 1 times d. Our a is 2, so n you're going to have minus 1, and our d is here is 4. So 4 times n will give you 4n, 4 times minus 1 will give you minus 4. So 2 minus 4 will give you minus 2. So we're going to have a 4n minus 2. So our Tn is 4n minus 2. So these are our general terms. So to now find out which is the first term to be greater than 31, so we're going to say 4n minus 2 must be greater than 31, and then find the value of n. So find the value of n, you move these 2 over, that gives you 31 plus 2, will give you 33. So then divide by 4, we're going to have n equals to 8,25. So the question, which is the first term to be greater than 31? And that will be the ninth term. So the ninth term will be the first term to be greater than 31, because our n already here by 431, our n is what? 8,25. So the next term will be the first term to be greater than 31. So it will be the ninth term. This our answer is the ninth term. I hope you understand that. I hope you do understand that. Okay. So the next question now. Now solve for x. Solve for x in this equation. We need to solve for x here. So how do you solve for x here? We have x squared equals to negative 5x. So what is the value of x? Or what are the values of x? So if x squared equals to negative 5, so the first thing to do is to move this negative 5x to the other side, so that we have our equation to be 0. We're going to say what? X squared minus plus 5x equals to 0. X squared plus 5x equals to 0. And then from there, if you have x squared plus 5x equals to 0, then you can factorize the binomial. So there, we're having it as binomial. You factorize the binomial, taking out one of the x's. So we're going to have x minus 5 equals to 0. So x minus 5 equals to 0, then x equals to 0 or x equals to 5. Again, we factorize that. We bring our 5x to the other side. So we're going to factorize now x into x plus 5, which equals to 0. That means x is equal to 0, or it's either x equals to 0 or x plus 5 equals to 0. So if x is equal to 0, that is sorted. And therefore the x plus 5 equals to 0, in that case, our x is equal to negative 5. So basically, our values of x are 0 and negative 5. I hope you understand that as well. 2.2, given b equals to 4 over 3 pi capital R cubed minus r cubed minus small r cubed. Make r the subject of the formula. Make r the subject of the formula. Given that b equals to 4 over 3 pi capital R cubed minus small r cubed. Now make r the subject of the formula. How do we go about this? So what does this mean in the first place? What does it mean make r the subject of the formula? Meaning we need to isolate r. Meaning we need to isolate r. We need to make the r to stand alone. So how do we do that? How do you do that? We first have to multiply both sides by 3 to first have to get rid of this 3. To get rid of this 3, we say multiply both sides by 3. So we have 3b. 3b equals to 4 pi r cubed minus r cubed. 4 pi capital R cubed minus small r cubed. Okay. So now next is to get rid of our 4 pi. Let's get rid of our 4 pi. So divide both sides by 4 pi. So divide by 4 pi, also divide by 4 pi, we have 3b over 4 pi. So 3b over 4 pi equals to capital R cubed minus small r cubed. Now find our small r. So we need to move our capital R away. So how do we move it away? So let's move the negative small r cubed to the left, and then we move the term on the left to the right. So that will give us small r cubed equals to capital R cubed minus 3b over 4 pi. Okay, and then to now find the value for small r, we take the cube root of both sides. Okay, let's see what is saying there precisely. So let's see what is saying there precisely then. Right. So now, so we're saying that that is the solution there. Our r becomes the cube root of capital R cubed minus 3b over 4 pi. To explain that again, the question says giving v equals to that volume of his sphere. We have two spheres. We have two spheres, big and small ones. So this is the change in volume of the sphere. So given that v equals to 4 over 3 pi into capital R cubed minus small r cubed. So the question is make the small r cubed the subject of the formula. Make the small r cubed the subject of the formula. So say the first thing to understand is we need to isolate the small letter r. We need to isolate it. We need to isolate it. We need to separate it. We need to make the subject of the formula. So to start with, we need to first multiply both sides by 3. We need to get rid of this 3 first. So get rid of the 3, we're going to have 3b. 3b equals to 4 pi r cubed minus 4 pi capital R cubed minus small r cubed. Again, 3b equal 4 pi brackets capital R cubed minus small r cubed. Okay. And next, we need to remove what? The 4 pi. So divide both sides by 4 pi, you're going to have 3b over 4 pi equals to capital R cubed minus small r cubed. Okay. And then next, we need to remove the capital R cubed. So to do that, let's move our negative small r cubed to the left and bring the term that is at the left to the right. So in that case, we have what is the small r cubed equals to 3b over 4 pi minus, we'll have capital R, small r cubed equals to capital R cubed minus 3b over 4 pi. And then to now find our r, we take the cube root of both sides. So finally, our small r can be equal to the cube root of capital R cubed minus 4 minus what? 3b over 4 pi. Again, cube root of capital R cubed minus 3b over 4 pi. Okay, that'll be our answer to that. I hope you do understand that. The next one, solve for x if 2 into 4 minus 3x is greater than or equal to 20. We need to solve for x. So how do we solve for x here? If 2 into 4 minus 3x is greater than or equal to 20. So how do we do that? So first thing to open up the bracket, we're going to have 4 times 2 is 8, 4 times minus 3x is minus 6x. We have 8 minus 6x is greater than or equals to 20. Okay, and then we collect the like ones together. Collecting the like ones, we move the positive 8 to the right hand side. So we're going to have negative 6x equals to, negative 6x is greater than or equals to 20 minus 8. Again, negative 6x will be greater than or equals to 20 minus 8. So 20 minus 8 to give us 12. 20 minus 8 to give us 12. So basically, negative 3x will be equals to, negative 3x will be greater than or equals to 12. And then we divide both sides by negative 3x. And then whenever you divide by negative value, you reverse the sign. Let's see the solution then. So this is what we have. So we're saying the first thing to do is to open up the bracket. Open up the bracket, we'll have what 8 minus 6x greater than or equals to 20. Okay, and then you move the 8 over. So negative 6x equals to 20 minus 8, which is 12. So now, to find your x, you divide both sides by minus 6. We say whenever you are dividing, whenever you are having solving problem with inequalities, and then you are dividing by a negative value, then you have to reverse the sign. Your inequality sign must be reversed. So if minus 6x is greater than or equals to 12, so x will now be less than or equals to 12 over negative 6. Because we need to divide by the negative value here, we need to reverse the sign. So x will now be less than or equals to 12 over negative 6. And that will be now x is less than or equals to 2. Okay, so our answer will be x is less than or equals to 2. I hope you understand that then. So the next one, question 2.4. Solve the following equations simultaneously for A and B. Solve the following equations simultaneously for A and B. So how do we do that? Solve the following simultaneously for A and B. So how do we do that? So A plus B equals to 12 and 4A plus 2B equals to 44. Okay, so how do we solve for A and B? Yeah? So call this one A plus B equals to 12 equation 1. Then 4A plus 2B equals to 44 as equation 2. Okay, so then you can say that from equation 1, let's make one of the variable the subject of the formula. Let's make one of the variable the subject of the formula. So we can make A the subject of the formula. So we're going to make A the subject of the formula. So we can say A equals to 12 minus B. A equals to 12 minus B. So if A equals to 12 minus B, then you can substitute 12 minus B for A in the equation 2. Okay, you can substitute 12 minus B for A in equation 2. And then we're going to have 4 to the bracket of 12 minus B plus 2B equals to 44. Again, we have what 4 into bracket 12 minus B plus 2B equals to 44. So if we multiply with 4, we're going to have 4 times 12. 4 times 12, that'll be 48. And then 4 times B, 4 times minus B, that'll be what? Minus 4. We're going to have what? 48 minus 4B plus 2B equals to 44. So 4B plus 2B will give you minus 2B. Minus 2B. So move the 48 now. The 48, move it over to the other side. That'll be 44 minus 48. And that'll be minus 4. So basically we have what? Minus 2B equals to minus 4. And then we divide both sides by minus 2. And then B equals to 2. Our value of B will be equals to 2. Our value of B will be equals to 2. So once we get our value of B as 2, we can now be able to find our value of A by substituting 2 for B in any of the equation. So substituting using equation 1, substituting 2 for B in equation 1, we have A plus 2 equals to 12. Therefore, A equals to 12 minus 2, so A equals to 10. We're going to have A equals to 10, B equals to 2. Okay, and then if you want to use the other equation to check, since our B equals to 2, if you put 2 by B, we have 4A plus 2 times 2 is 4. And then when you move the 4 over to the side, we have 4A equals to 44 minus 4, which is 40. Okay, and then from there, we're going to say 4A equals to 40, and then A equals to 40 over 4, A equals to 10. So basically, A equals to 10 when B equals to 2. Okay, so our value of A is 10, and our value of B is 2. I hope you understand that. Okay, the next one, SIPO is 7 times older than its son. SIPO is 7 times older than its son. In 25 years' time, it will be twice as old as his son. By formulating and solving an equation in X, calculate the son's present age. Look at that. SIPO is 7 times older than his son. So let's say his son's age is X, then SIPO's age will be 7X. Okay. If SIPO is 7 times older than his son, so we're saying let the son's age be X. So if the son's age is x, that means people's age should be 7x. So now people is 7x, the son is x at the moment, okay? But in 25 years' time, he will be twice as old as his son. In 25 years' time, he'll be twice as old as his son. In 25 years' time, it implies that what we're going to say, 7x plus 25, and what? For the son, going to be x plus 25. So at that age, he'll be twice as old as the son. They're going to say 2 bracket 7x plus 5 plus 25 is equals to x plus 25, or x plus 25. 2 times x plus 25 is equals to 7x plus 25. Okay, so again, Sipo is 7 times older than the son. So we're saying the son's age is x. So Sipo's age is 7x. Now, in 25 years' time, so in 25 years' time, both of them will have aged by 25. That means you're going to add 25 to both of their ages. So that means Sipo's age will now be 7x plus 25, and the son's age will be x plus 25. So, and then as at the 25 years, he will be twice as old as the son. So that means you cannot say, for us to equate, put the two ages together, we'll say 2 times the age of the son must be equals to the Sipo's age. And then don't forget the age of the son is x plus 25. So 2 times x plus 25, 2 times x plus 25 must be equals to 7x plus 25. And then when you do that, so 2 times x will give you 2x, 2 times 25 will give you 50. So 2x plus 50 is equals to 7x plus 25. Again, 2x plus 50 equals to 7x plus 25. Okay, so if you bring the 2x to the other side, you're gonna have 7x minus 2x, that'll be 5x. And then if you bring the 5 years, the 25 minus 50, that gives 25. And then you subtract and divide both sides by 5, we have what 5. So x equals to 5. The parent age was 5. Okay, that means the son's age at the moment to be 5. I hope you understand that too. Now the next exercise we're looking at is find the value of the square root of 33. The value of the root of 33 lies between two integers. Find these integers without finding the exact value of 33. Again, the value of square root of 33 lies between two integers. The value of square root of 33 lies between two integers. Find these two integers without finding the exact value of 33. So to do this here, how do we do this? So we're basically going to find the perfect squares, the square numbers that precedes 33 and the one that comes after 33. Again, we look for the square numbers that comes before 33 and the one that comes after 33. So before 33, square number before 33 is going to be 25. And after 33, the square number is going to be 36. So the perfect square before 23 is 25, and the perfect square after 33 is 36. So that basically the square root of 33 is between the square root of 25 and the square root of 36. The square root of 35 is 5 and the square root of 36 is 6. So basically, root of 33 is between what? 5 and 6. Okay. So root of 25 is between 5 and 6. Because 33 is between 25 and 36. Therefore, root of 25, root of 33 will be in between the root of 25 and root of 36. Root of 25 is 5, root of 36 is 6. So that means what? 33 is between integers 5 and 6. I hope you understand that there. And 1.2, convert the following recurring decimal fractions 0.45 to a common fraction in the simplest form. Again, convert the following recurring decimal fractions 0.45 to a common fraction in this simplest form. So how do we do this? How do we convert from recurring decimals to a common fraction? So to do that, what we say, we're going to say x equals to, 0.45. 0.45 recurring is indicated like this. We represent a recurring decimal 0.454545 with just 0.45 with what? A dot on each number. So the dot on each number indicates that what? The 45 are recurring. The digits 45 are recurring. So the dot on these two numbers indicate that the digits 4 and 5 are recurring. So what does that mean? That means our actual value is 0.45, 45, 45, 45, 45 to infinity. So now, how then do we find the common fraction form of this decimal? So what do? We say x equals to 0.45, 4545. You write the 45 in twos, just like 245, and then with the last 45, you put the dot on top. And then what do? You now multiply both sides by 100. Again, you see x equals to 0.45, 45, 45, 45. Okay, we represent x to b to give us this number because 0.45 with a dot means 45 is being recurring. So x equals to 0.45, 45, 45, 45. Okay. Next, what do? We multiply both sides by 100. So we're going to have 100x equals to 45, 45, 45. And then what then we're going to do? We subtract these two, or rewrite this. Rewrite this step, rewrite it here, and then subtract these two. So 100x minus x will give you 99x. So 45, minus 0.4545, you get what? 45. When you subtract this away from this, then you get 45. When you subtract 100x minus x, you get 99. Therefore, x equals to 45 over 99. X equals to 45 over 99. So when you simplify that, you get 5 over 11. 5 into 9 into 45 is 5. 9 into 99 is 11. So when you punch in your calculator 5 divided by 11, then you're going to get on your calculator 0.4545454545. That means this is the common fraction of this recurring decimal fraction. I hope you understand that too. I do hope you understand that. So let's see the last example for today. I'm simplifying this expression 3x to the power of 2 minus 2 into xy all to the power of 3 over 2 to x power 5 y power 4. So what do? When you have questions like this, you simply distribute. You distribute the 2 on the x and on the 3. Here also you distribute the 3 on y, on the x, and on the minus 2. And that will give you 9x squared. You're going to have 9x squared. You're going to have about negative 8x3 y3. Again, 9x squared here, negative 8x3 y3. And they can now say the 9 multiplied by the negative 8, that will give you negative 72. Now negative 72, x what? x5, y3. And then that will be divided by 2x power 5, y power 4. Negative 72 divided by 2 will give you negative 36. And negative 36, x power 5 cancels x power 5, y power 3 goes out of y power 4 here. We're going to have y power 4 in the denominator. Basically, our answer will be negative 36 over y. Okay, negative 36 over y. All right, so that will be our solution to that. Okay, and then for the last one, 1 over p minus 1 minus q, brackets 1 over p plus q, minus p over minus q over p squared into 1 plus q plus p squared. So to simplify this, what do? You just open up the brackets, you follow this. 1 over p times 1 over p, that gives you 1 over p squared. 1 over p times q, that gives you q over p. Then negative q times 1 over p, that gives you negative q over p. Negative q times q, that gives you negative q squared. In that case, we'll have what? 1 over p squared minus what? Q squared. So this will give you 1 minus 1 over p squared minus q squared. And then this one is going to FOIL as well. And then when you FOIL, you use this here to multiply the two brackets, to multiply the two terms in the bracket. Minus q over p squared into 1 plus q plus. So 1 times q give you q, p squared times q give you pq. Okay. And then minus times plus give you minus what? P squared cancels what? P squared, and then give you q squared. You're going to have q squared. You're going to have q. Then we have 1 over p squared. And you can now combine it with our 1 over p squared plus minus q squared here. With this here, then you can simplify it and get your final answer. I do hope you understand that. Thank you for listening, and then enjoy the rest of your day. Next lesson, we'll be looking at more revision on algebra and patterns. Thank you for attending, and then enjoy the rest of your day.